Good morning, class. Today we will discuss about bipolar junction transistor fundamental. So in this chapter, what is our learning outcome? So first one is to describe the physical structure of your transistor and also the terminal identification of PNP and NPN transistor. We have two types. So second, you will able to explain the DC biasing method and also determine the transition operation point and calculate the key parameter. Okay, for example, IC current, IB, your voltage collector and emitter, and etc. Okay, the last one, at the end you able to interpret the transistor bias circuit characteristic. Okay, so we will go to our topic. So first one is introductions. Second is bipolar junction transistor. Third one is your basic transistor operation. Number 4 is the transistor characteristic and parameter. And number 5 is application. Then we will go to transistor package and terminal identification, DC operating point, and also transistor AC equivalent circuit. Okay, so first one. Okay, introduction for transistor. So they normally use for amplifier. They amplify the sound, control as a switch to on off BJT lah. They kuatkan suara. Amplify mean they make the sound become bigger. Okay, and then they become the switch to on off and also act as a current control device. Current control device to control the current. Okay. Okay. So we have amplify the signal. Could be an audio, could be some high frequency radio signal. Also can be the also it have able to do without distortion of original signal. Okay, which means no distortion, no noise, no changes. Distortion means changes lah, something influence. Okay, so we have two types. We have type A and type B. Okay, so as you know, for type A, we learned previous class, right? Inside chapter 1 have diode. Okay. Inside diode, we have PN junction, correct? Still remember? Still remember what is PN junction? Okay, so PTT is special a bit, they add one more part. So, they got PNP and NPN. P junction, N junction, then add one more N junction. 3 lah. Okay, like for example lah, okay? What's the name? Vanilla, okay, vanilla backup. Okay, vanilla is the P, then N come backup. N. Okay, this one is PN junction lah. Kalau duduk sebelah-sebelah. Ada transaction of energy. Okay, then if NPN, which one we want to add? One more N. Okay, one more N come. Okay, one more N and another duduk sana. Then this one we call as NPN. Understand? So 3 of them connect together and connect to the electric. Okay. Understand? So what will become collector? C we know as collector. Example, she is the collector. She collect the voltage coming in. Okay. He will become the base. Only satu laki kan, only one man here. And then he has to be stable lah. Got 2 female, right? You know which one to choose. Stable, base. Become the base. Example only, don't think so much. Then this one is emitter, to emit the electrics. Understand? Okay, this is the combination lah. Okay, we go back. Okay, this one now we Go and PNP. PNP same also. Come one side. Okay. And PNP like this P and P. It's combined together. Now because she has to be the base. She has to be stable. One collect the current, one stable, another one emit. Okay, understand? And then between them got the gap. Gap is the electron transfer. Ingat kan? P-N junction we have gap right? If 4 wires is narrow or bigger? Okay, narrow is pandai. Okay. So you can see here. Okay, if you can see here, we have two types. Just now I explained already. We have 3 dropper or semiconductor region called as emitter, base and collector. 3 region. So 3 region And then this 3 region is separated by the PN junction. So we have 2 types of the BJT. One is PNP, another one is NPN. Okay, they separate by a thin P junction between this NPN. Okay, between the P and P, they separate by and this one NPN. They have 2 regions separate by a P. Okay, and then P and P they consist of 2 regions of P, and then they separate by the N. Like this now 2 females separate by 1 male, and then 2 male separate by 1 man. Like that. Okay. So the emitter function as a current supply or the carrier. The collector role. Okay, emitter is they emit. Their function is as a current supply. They emit the current. Collector is to collect the charge or the circuit operation. Base is to control the junction to control. Have to stable. I say base control. They have to stable the current. Then how you remember when you see this emitter, nampak E means got arrow, emit Where you want to go, emitter, got arrow, okay? So N, you have to be arrow out. P, you have to arrow in. The difference, can you see? Easy to remember. In bahasa P is pintu. Pintu P. Door. In English called door. So this one, this P, the arrow going in P. Then you ingat pintu masuk Then P and P lor. I remember like this You can remember use your way Okay. Okay. Then Now this one is the diode with PN junction Normally we have diode just 2 junction. Now BJT you have 3 layer with 2 PN junction. Here got 1 emitter and base 1, and then base and collector 1. Can see Okay. So from here we can see N and P, which is the base and collector junction. Can see here now. Okay. Another one is P and N, the base and emitter junction. Okay, which means the gap between the just now P and N and then P your friend. Okay. Okay, this one is the junction. Okay. Now I tell you about so you can draw like this This one is a drawing. You can draw like this. In symbol is this one. This one is symbol Symbol you can draw like this. So inside the symbol you draw like this. In terms of figure you can draw in terms like this The drawing. Okay Okay. Now we go to the gap. Tak gap lagi Okay. So you can see PN junction, they must be supplied with the external DC voltage. Okay, for both NPN and PNP, the B and E junction is forward bias. This one, the emitter and the base. Emitter and the base must be forward bias. So just now you told me forward is narrow. So here they must be narrow. This region. So the if you go see this one, this one, okay, this one must be narrow. Here must be very close. Then the BC junction must be bigger. Okay. Because the power supply from the collector, they will supply inside here and then they will turn one round. I show you the video lah, how it's done. Okay. So you see this one? Okay, you see here. So forward bias and the reverse bias. However, the diode polarity, however the bias voltage polarity and the current direction are reversed between these two junctions. Okay. This one is the power. We have two power supply. BJT we must use two power supply. So one is power supply is from the base. Another one power supply is from the collector. So here one power supply you supply to the collector. Another power supply you supply to the base. So when this one supply to here we will have reverse bias. You see positive, positive, negative. Okay, here you see you coming in here and then here will be forward bias. This part forward bias, this one is reverse bias. So you have two power supply. Okay, same go to here. Here you have to reverse your battery for the NPN. So only you can get, here is reverse, here is forward. So the forward bias for emitter is narrow. You remember here is narrow. Another one, the base and collector to be widened. Base and collector to be widened. Because here got power supply. When got power supply, it will make it wide, narrow up lah later on when power supply coming. Okay. This one is the explanation. This one, okay, you see this one. This one is the current. How the electron go. You can see from here, the electron is reverse the current direction. Electron yang merah ni electron. Dia akan bergerak, enter here. Here is your emitter. Now I talk about electron, not current. Electron is reverse of the current. Understand? So your current your electron is from positive to negative from the battery. You will come to the emitter. Okay, from the emitter they will go to the base. So this one is forward bias lah. And then from here they will go to the B and C junction, go up. This part, they're going up, and then they will go to the collector, the electron, and then they will go out here. Then again, so some of the current they will go to the base. Can see or not? This one is how the current go up. So I show you in terms of video, you will see it more clearly. The for example, NPN transmitter, the transistor, the electron at the emitter is being pushed to the negative terminal power source. So through the junction of P-type, the base is slightly dropped and very narrow. They explain about this figure. Okay, they explain about this one. They push about here will be narrow. Okay, the explanation in theory lah. Okay, and then the B, you see the base is very narrow and smaller percentage of electron flow from the BE junction can be combined to the holes and flow out the base. We call as the electron forming small base current. So which means you see from this one, the current flow to the base is very less, like just how the video show. So this one will be, here is narrow and the current flow to here is very less. This acts as a switch that can be controlled. Okay, so we have to calculate Here we call as IB, base electron current. This one is IB. IB, the symbol, IB, current. Current is I, B is base. Okay, here is the current for the base. Okay, and here we can call as emitter electron current, IE equal to IC plus IB. IC is the above. This one is IC. IC is the collector current. Above is collector current. Okay, can see above. And then here is the IE. Here is IE. Okay, IE actually is IC. You see here go this side, here go this side. At the end, they combine. So C add with B, you can get IE. Okay, understand? This is just the formula lah. So this one is the explanation of like whatever the video show you. Okay. Okay. Now the current inside transistor is the summation of collector current, base current, IE equals to IC plus IB. So you can see here is IC, that you see current coming in here, IB coming in here, two current coming in. These two add up, you can get IE. Nampak tak? Boleh kan? Can or not? This one. This one is your collector, this one is your base. These two coming in, you add up, you get your emitter. Same for this one is the NPN junction. Okay, PNP junction, they are the other way around. So the IB is smaller compared to the IC, so we assume if they are smaller, we assume IE equals to IC lah. If this one is very, very small. Okay. This one is for PNP junction, IE is here, you go out is 2, this 2. This one is PNP junction. Reverse. Okay. Also same lah, IE equals this one and this one, you get this one. Because here you can go this way and go this way. Okay, just reverse. Okay, now we go to the characteristic. Okay, the transistor connect to DC bias voltage. Okay, VBB is this one, voltage from the B. So we know it as VBB. Okay, voltage from the base. Okay, VBB forward bias. And then forward bias, the this one, the BE is a base emitter junction lah. Okay, VBB here, you go through here. Then nampak tak? I show you. I will show you with coloring. Okay, here. So here VBB, nampak? Tak nampak? Red color lah. So here VBB, you coming in, you pass through here. Okay, this one VBB, okay, at here BE junction, this one we call as BE junction, is forward forward bias. Okay, this one is F, forward bias. Can write. Okay, this one forward bias. Okay, then normally this one, okay, VCC reverse bias SVC. Okay, here is reverse bias. Okay, this one is the voltage for VCC, collector voltage. So normally VCC is direct from the supply. It is smaller from the voltage divider. Okay, this VBB is from voltage divider and VCC is from the voltage supply. So you connect to supply. So this one from here, the current for IC, another current from IB. Okay, faham? So when the transistor operate within a linear limit, IC equals to beta IB. This beta is the gain. Beta is gain. Okay. where this beta DC beta is a current gain of the transistor. Nampak kan? This one. This one actually is your beta DC. Okay? And the transistor usually to design a H as a HFE. Okay? And the value typical is 20 power of or 200 smaller signal transmission. This one is the value of the signal lah. So we seldom use this one. You remember this formula. This formula is very important. This formula you memorize. You must memorize this formula and also this formula. These two. Memorize. Okay Okay. Okay. So this one is for NPN Okay, when goes to PNP, same also, just the direction of the current is different. Okay, here also is forward bias. Here also is reverse bias. For the BC, BC, this one is BE, forward. Just the direction of the current is different. You go this way and go this way. The formula is the same. IC equals to beta IB. Formula is the same. Faham? Just the direction of the current difference. Okay. So the ratio of IC and EC can be IC and IE can be calculated alpha beta. This one is another formula. Alpha DC equals to IC divided by IE. This formula must remember. Okay. So this alpha must be in the range of 0.95 until 0.99. They always less than 1. Okay. So later on you calculate, if not in this range means wrong your calculation. Okay. The proper operation of the beta transmitter junction is forward bias by VBB and conduct like a diode. So collector bias junction is reverse bias by VCC. And they block the current flow junction like a diode. This one is the collector base. Collector base. This, if you have one collector, okay. And here, this one is your collector, this one is your base, this one is your emitter. So at the B collector base, this one is reverse bias. So when current coming in here, your VCC, right? So they block the current like a diode. Here, because it's reverse bias, they block the current. Faham tak? And then the current go through the junctions, the diode. Okay. When current go through the emitter, okay, here, this one forward bias. They will help to stabilize the current flow from the collector to the emitter. Here is to stabilization. Here is to block. CB is to block. BE is to stabilize. Faham? You remember like that. Okay, Okay, now we go to the questions. Calculate the alpha equal and beta for IE and IE when IB is 10 milliampere and C is 4 milliampere. Anytime got marker pen This marker pen I didn't bring my anyone got marker pen? Aku ada tomorrow plus IB. Betul kan? Okay, second formula is what? Beta equals to what? What? This one? IC divided by IB kan? Okay. IC divided by IB. Okay, alpha what divided by what? IE. Okay. Then you use these three formula in the table lah. So for question A, find alpha, beta, and IE. So first you find IE first lah. IE equals to your IB is how much? 10. Your C is 4. So you take 4 milliampere plus with 10 mil. So you get your how many? 4 milli what? 110. Betul tak? Betul kan? Calculator try. Then second data equals to IC. IC is how much? IC divide IB. So IC is 4 milliampere. Betul kan? Divide by IB is how much? 10. Divide by 10. You divide, see, get how much? 400. Okay, and then alpha, you do IC is divide by IE. IC is 4 milliampere. IE, the one you calculate. You put 410. 4.01 kan? Pula. Katanya betul. Korang 4.01 kan? Pula. Saya tanya betul. Jangan ikut jawapan saya. 4.01. Okay, how many is that? Beta how much? Huh? How much? 400. Okay, this one no unit lah. You see ampere divide ampere no unit lah. Okay, this one alpha? 0.99. So dalam range lah, correct lah. Okay, so easy ah. Now you do for B. So this one answer for A, you do for B. Then we check answer. 5 minute rest lah. Atau this one lah. Okay, everyone. Okay, everyone get the same answer for question B? So IC, you get beta multiply IV lah, so you get 10 milliampere. IE is IC plus IB, so you get 10.1 milliampere. So this one, alpha DC, you get 0.99. Can ah? Okay ah? Okay, so for question B done. Okay, now we go to okay. Now we go to current voltage analysis. There are 3 DC voltage and 3 key DC current to be considered. So you can see here we have IB is your base current, this one, base, okay, IB. Then IE is your emitter, DC emitter current, here, IE, okay. And then we have IC is your collector. Okay, when you see this photo, first thing you must know, this one is NPN or PNP. NPN or PNP? Again? NPN, yes, you are right. So how you know? You see the arrow going out is N. Okay, arrow going out is N. Okay, then VBE is the DC voltage cross the emitter, so you know lah, voltage for B and E. Okay, next one is a voltage cross the collector and base, voltage for CB. Okay, and then you have voltage for the CE here, between C and E, this range. Okay. So this one is the collector to emitter lah. So you have to, this is all information later on you need to calculate. Clear? Okay. Now we see the calculation formula. To analyze this transistor circuit, we have to use DC voltage current, okay, because this is DC voltage lah, all is using battery. The most important one is you must use Ohm's law and Kirchhoff's law. You learn electronic circuit, right? You remember Ohm's law, right? V equals to IR. Okay, Kirchhoff's law is what? Kirchhoff voltage law or Kirchhoff current law? Kirchhoff voltage law is all the whole circuit you add up equal to 0, right? That one is voltage law. Current? Tak ingat. Kata apa? Ingat? Tak ingat. Okay, it's okay. Never mind, you tak ingat, never mind. We just memorize this one. Remember this one, okay. First, we know voltage bias, right? Voltage bias, do you remember voltage bias? Diode for voltage bias, correct? How much voltage bias for a diode? 0.7. So first is voltage BE is 0.7. This one is always fixed. If the question give you, then you use the question value. If the question didn't give you, you use 0.7. Like inside your lab, right? You measure your diode is either 0.7, some you get 0.84, some is you get 0.79. Correct, right? You're using the multimeter to measure one, still remember? That is the VBE, or your voltage bias. So normally, in theoretical, we just use 0.7. It's the fixed value. Unless in practical case like that, it depends on the device. They got some vary lah because of the development of the device. Okay. Theoretically calculation 0.7. Some question they will ask you use 0.65. That one is germanium or 0.4. These two types, they will ask you use 0.4 or 0.65. It depends on the question now. If they say using germanium. Silicon normally is 0.7 or 0.65. Okay. But if the question not given, assume 0.7. What's the easiest one? But normally I will give that. Okay, then to calculate the voltage, okay, we have first formula is VBB minus VBE equals to voltage R. Okay, voltage this one RB. Voltage RB, okay. Voltage for the RB, which means is here. VBB, okay. The current go through here one circle. VBE, so this one minus of this one, you will get the current for the RB, this one. Nampak? Can see or not? Now, one more time. You see, VBB is here, RB is here, your resistor. So this one minus of this one, you get this one. Actually, it's this one plus this one plus this one. So if you want to find this one, you take this one minus of this one, you get this one. Because you go through in. Kirchhoff law, you remember or not? Kirchhoff law is VBB plus VRB plus VBE equals to 0. Done. So you want to find this one, you take this one minus of this one, you get this one. That's easy. Okay, second one is to calculate this one. When you get to VRB already, you want to find the current for here, IB, current IB, right? You just take the voltage of your resistor, divide your resistance. Ohm's law, V equals to IR. You take V divided by your R, you get IB. Okay, next one. This circuit center, this part. Okay, now you go to another part. VCE is here. VCE is here. Okay, if you want to find this VCE, this one is the whole circle. You see this side now? From here, battery going up, and then pass through here, it go down here. You don't consider this part first. Okay, so here, VCC, you have to go here, minus of your VRC, then you will get your VCE. Kirchhoff voltage law lah. VCC, you plus with your VRC, you plus with your VCE, actually you get the circuit, the whole voltage here equals to 0, correct? So if you want to find that one, you take this one, you minus out this one. VCE, VCE. You have to take VCC minus out VRC, you will get your VCE. Okay, VRC, the voltage for this one is current, V equals to IR, current multiply your R. So, current multiplies your R for your RC. Easier, Okay, next one. Okay, to calculate the gain, beta equals to IC divided by IB lor. Find the gain. Or reverse it lah, you can get your IC. This one is fixed. Okay, then last one, VCB. CB is where? Here. Here you done already, here you done already. This one you don't know. To calculate this one, you take your VCE here, because one now is inside. Don't consider this outside, no more already. You just consider this circle. This circle. So this circle VCE, you minus off your VBE, you can get your this one. You calculate inside the circle. So this boleh kan? This thing you define into 3 parts. One is B, one is C, another one is inside the circle. That's all. If you understand the formula, the concept, later on how it changed, it will just using this concept only. You no need to memorize the formula also can. Understand? Boleh kan? Okay. Now we straight away go to the question. Can. Okay. So see this figure. Okay. If your beta is 100, calculate the base collector, current emitter, and also your VBE, VCE, VCB. Okay, calculate. Use just now formula. If didn't do that formula, also can calculate. See here also can calculate already. No need to memorize formula, also can calculate. And then they want IE, history, regular. Then they want BBE, and then they want BCE, and then they want BCD. Then they give you all these. Okay, first you want to calculate what first? Mana satu ni saya dulu kena calculate? Which one you want to calculate first? IB first lah. So you want to calculate your IB, this one, IB Okay. IB. You want to find your IB. So how to calculate IB? Macam mana? What to calculate IB? Balik tengok formula. IB, you must have the voltage V, VRV, V equals to R1. Kan, this one right? Okay, so formula number, these two, this one. Okay, so to get your VRV, okay, it's the voltage across here. This one right? Okay, so this one minus of VB, V minus of VBE. So you take your VBB minus of VBE divide by your RV. So it's this circle lah. You want to find this one. So this one minus of this one. This one is your I write wait. Okay, this one is your V, B, E. Okay, at first you must know this one is NPN junction lah. So this question is NPN. Okay, first thing. Okay, this one number one. Step number one you must know is this one. So step number two, you find this one. Okay, you use your VBB minus of this one. So your VBB is how much? Okay, put here lah. 5, how much VBE, VBE pun tak tahu kan? VBB kan? VBB is 5 volt minus of VBE. Mana ada? 0 point? So second value fix tak tadi. Okay, so divide by your R is 10 kilo ohms. So you get your answer. Boleh? Okay, then number 3. Okay, you done this one, then you can find your IC. IC formula beta multiply I apa? IP. Okay, so your beta 100, your B berapa? Your B how much? 430 mil ampere. 430 mil ampere. So you put in 430 mil ampere. So you multiply 100. So you get 430 milliampere. Tak, bukan 0.43 ampere. Bukan 645. Berapa you dapat? Yang ni? Betul? 100. Sekarang 100 kan? Beta. Untuk A, question A, 100. 100 maaf, cara. Ini kita betul tak? Dah.
Our slide, our beta is 150. In our slide is 150.
Your slide is 150. And then what you go back calculate yourself. 100. Slide 1, you go back calculate yourself. Now we using this one, 100. Slide 1, your homework. Slide 1 is your homework. We use 100. Now my question is 100. Berapa? 430, right? Milli, okay. Then next one, your slide one, you go back homework, Don't ask me to. Later, it's the same step lah. You go back, just change the value, change 150. Okay, next. Next, you want to calculate what? I see done already, IE. IE formula what? IE. Just like the IE, arrow going in, you will have two, IB and IC. So, IE equals to IB plus, you don't need to C formula also can. So, C is how much? 43 milliampere plus IB 430 milliampere. So, you get your answer. Okay, now we go to VBE, you get already, ma? Okay, done. So now we VCE. Okay, CE. CE is where? CE is here. VCE. VCE. And then here is VCB. Okay, VCE how much? Okay, formula equals to VCC, just sama dengan CC, because here right, current going in, you minus off this one, you get this one. Okay, minus off with the IC, RC. Okay, VCC is 10 volt, minus off IC, where? Okay, for 42 milliampere, RC is 100 ohm. So you get your answer. Okay, last one. VCB. VCB easy, right? You take your VCE plus minus of minus kan?
Yes.
VBE. So your VCE, what value you minus off 0.7 volt. You get your answer. 2, so you get 106.8 milliampere. Boleh kan? Okay. Then IE is here. Arrow going down. So you take your current IBB plus with your ICC, IB plus IC equals to IE. So you have 890.2 mil plus with 106.8 milliampere, you get 107.7 milliampere. Okay. Now your VCC is 12. So if 12, you minus off this value. Okay, 106.8 multiplied 220, you get, I think you get a bigger value, 20 something. 20 something, I think. 23.5, if not mistaken. So you might, if you minus, you get minus. So your voltage is negative 11.5. Okay. Okay, you just use the negative one, all those are negative. Okay, and then your VCB is equal to VCE minus of VBE. So negative 11.5. You minus off your this one, so you need extra 12.2 voltage lah. So this one is the offline one lah, not function. Okay. Done. Now we go to next one. So exercise in the slide you do at home. Already given the answer. So maybe if have time, we will discuss that class or in the tutorial. Okay, I will discuss in the tutorial later on. Okay, now we go to collector characteristic curve. A set of collector characteristic curve can be generated to show how the collector current vary with the collector to emit the voltage VCE for specified value of the base current. So this one we will vary. We want to vary the VBB and vary the value of VCE. We can see the characteristic of your IC, the character of here. Okay. So now we go and see. Now, okay, you assume to see the characteristic. Okay, this is the characteristic curve lah for your transistor. So first we assume the VBE is set at a certain value. Is set to produce a certain value of IB. Okay, this one we fix a value first lah. IBB we fix a value. Then the ICE will be equals to 0. Okay, this one is the current for IC. This x-axis y-axis is IC, and the x-axis is VCE voltage. Okay, first we set this VCC is 0, and then the BE and the BC junction are forward bias because your B is your B is 0.7 because your transistor is have the original regular voltage bias 0.7. Okay, so your E and C is 0 here. Okay, point A. Can you see this on point A? Okay, at 0. So when the current, the IB falls through the BE, it will cause the low impedance. So to pass the ground, so your IC is 0, the transistor is in the saturation region. This region we call it saturation region. Any value below than the the voltage bias. Okay, which means now you see this circuit. Which means this circuit, now I set some value, maybe 5 volt here lah. 5 volt. Okay, so the current will keep flowing this way. Okay, and here, because I see no current, so this one is 0. No voltage. If no voltage means no current. So no current pass through. This is what okay, this is what they explain here lah. C is 0. So here no current. So at beginning your VBE kan? VBE okay, this one is C. Okay, VBE here is 0.7. This is what meaning lah. Here got current pass through, here nothing pass through, here always remain 0. Here is 0, here got 0.7. So now whether any value pass through before 0.7 is saturation. Dia tak achieve lagi, tak lebih, not more than 0.7. Is saturation region. Okay, understand? So this one, okay, now is saturation region. Okay, now we slowly increase VCC. Slowly increase this one. We slowly increase VCC. So when increase VCC, your VCE will increase, your IC will increase. So it will show a point from A to B. Slowly increase until B. Okay, at one point they will more than 0.7. Okay, this one. Okay, slowly saya increase lah. This one I put. Slowly I put 5. Slowly I put 1 volt, 2 volt, 3 volt until 5, 4, 4, 5, 6 until more than from 0 lah. 0, 0.1, 0.2 until more than 0.7. 1, 2, 3 already, right? More than 0.7, right? Slowly this one will increase. When I give the value 0.1, 0.2 until more than 0.7, here are the voltage 0.7, it will increase. The current also increase. So this one is the current IC. Also increase. So when until this point, it will when more than 0.7, due to BC is forward bias, this curve become flat. No increase of IC already. Okay. This region we call as active region. Means it actively function. Faham tak? You punya resistor sudah start function. Because the voltage is more than 0.7, if the BCE, BC, the base and collector here, they start function. Here. This one start function. Okay, so we call it active region. Okay, after that, once more than this value, threshold point, we got one threshold point now. Okay, one more than this value is breakdown. Sebab tu, later on you enter your lab, later on we enter lab 2, lab number 2 lah. We will have one experiment ask you to adjust your VCC. You have to adjust your VCC until one value lah. Maybe is 15 or 16 watt and above, or 25 watt. Last year got your friend, your senior lah, adjust until 30 watt, and then the resistor burn and come out asap. That means breakdown already. Your resistor breakdown. So you don't give too many value until your resistor burn. Last year what happened? That is, the whole lab become hangus. The smell, bad smell. It's burnt. Everyone is burnt with the smell. So when you enter lab, you have to be careful lah. Okay, this is what's meaning. Okay, Okay, so when the VCE is more than 0.7, the VC become reverse bias, and the transistor go to active and linear region. So this region, active region. Okay, and IC will remain constant. Okay, you see your IC, your current value here. You see remain constant. The IC remain constant. Okay, after constant already, actually the IC is increased equals to IC beta IB, just slightly increased due to the very widened BC dissipation. And because a few hole is recombined and the beta is increased slightly. So this is a relationship lah. The IC and VCE is with IB. So the relationship is the greater increase of ICE and VCC. When VCC increase, this VCE will continue increase. This one also will increase until it reach the breakdown point. But this IC is the same. This IC is the same. And the linear region until the breakdown point. Okay, the meaning of this one. Until this breakdown point, it will remain the same, but your voltage is increasing lah. Your voltage, you see the voltage ICE, VCE is increased. This one is increased, but your IC is same. This is a word explanation. Okay, in word. Okay, so you can measure lah. So the family for IC and they have several value lah for this. If you have different you set different, for example this one IB you set at 0, it will have smaller lah. If your IB you set higher, maybe you set 1, 2, 3, 4, 5, so it will, this one IB where we set based on initial I say you set this value right, this one we set, so we can set maybe 0 watt, 2 watt, 3 watt, and then we adjust that one. At first we set 0 watt and then we adjust VCC. So you can get the curve, this curve. This one. At first we set the VB at 0, your IB is 0, so you'll get this curve. If later on I set the VB is 1 or 2, you'll get this curve. And then you set 2, you'll get this curve. You set 3, you'll get this curve. 4, 5, 6, like that. And then you vary your VC. Faham tak? Faham kan? Boleh faham? Anyone know understand? Clear? Clear. No raise hand in understand. Okay. Now we go to exercise. Sketch the ideal diode when your IB is 5 milliampere to 25 milliampere at in the 5 milliampere increase and the VCE is not exit breakdown. So you have to draw this curve lah. So you can, how you draw? You have to do a table and then you do the calculation, you only can draw. So now we do the table first lah. So okay, I straight away draw the table here. Okay, first you have to put your IB. Okay. Then with respect to your table is IC. Okay, now your IB value is 5 milliampere, right? So you put 5 lah, 5 here. Okay, increase until 25. So you increase every 5. So if 5 milliampere, next you add 5, you get 5 add 5, how many? 5 plus 5, you get 10. Okay, and then 10 plus 5, you get 15, and then 20, and then 25. Okay, milliampere lah here all same. Okay, then you can calculate your IC. You calculate your IC. Okay, to calculate your IC, your beta is 100, right? So your formula IC equals 100 multiplied with your IB, kan? So you calculate here. So you get how much? IC you get 0.5. Correct? Huh? Multiply 100. 5 mil multiply 100, you get 0.5 milliampere. Okay, and then here also same. You multiply by 100, you get 1 milliampere. And then you multiply all lah. Then you only start to draw. So you draw the x-axis is VCE. Okay, this one I draw there lah. Same only. It's actually same only. You just draw the curve. I show you here is that you more understand a bit. Same only. You just take your IC milliampere and then you draw your VCE. Okay, and then here is 0, and then you put 0.7. Okay, then here you can put saturated region. Here is active region. Okay, and then you put one more to the top. Okay, here is breakdown region. Okay, breakdown region. Okay, BD lah, breakdown region. Okay, and then you just draw first one. First one is current is agak-agak lah. So this one I see, right? Okay, I see. Okay, here 0.5, and then next one is 1. This one is 1.5. Next one is 2. Okay, until and above. Then you first draw this one. Then slowly up a bit. Agak-agak lah. This one is just roughly lah. This one just roughly, and then this one is you IB 5 milliampere, and then the second one. Okay, this one is because it's just slightly, and then this one, then this one. You just roll like that, then label, then finish. So you get that. Okay, So done for this question. Okay, now we go to cut off. So, okay, what is cut off? Cut off happens when your IB equals to 0. Your base current is 0. Your transistor is in cut off region. So which means you see this figure, you didn't have any voltage supply from your base. So here no supply. So when here no supply, you just consider VCC, RC and VCE. So here no supply, your VCC is approximate same with VCE. So in practically no current in the collector part of this circuit. So there are very small leakage. So leakage current, collector leakage current is ICEO. This one, we know this one as current collector leakage. Okay, very small. So we can assume VCE is equal to VCC. Okay, and here, this one, both are reverse bias. This one also reverse bias. This one also reverse bias. Because no current. Off. Cut off. Means off lah. Okay. When saturation happen, okay, saturation will happen when BE here base emitter it will become forward bias. Okay. So at here your current IB will increase. Your IC also will increase. Okay. These two is increase. IB and IC increase. Your VCE is decreased. VCE is decreased. Because V equals to IR, V equals to IR. Okay. This one VCE is decreased. This one increase because voltage for the resistor is increased, your C will be decreased because this one is increased. Because I increase, C also increase, your V also increase, right? Here is increased, so VCC is fixed, you minus increase, so your VCE will be decreased. Nampak? Faham kan? So when your VCE is saturated, your VBC, so at here, this one will become saturated. So this one saturated, here will become forward bias. So this IC cannot increase, even the IB is increased. Here lah. Even your IB increase, your IC cannot increase. Saturation. Okay, once the IC maximum, the resistor said to be saturation. When the IC become maximum already, the transistor is saturated. So Ohm's law happen, IC saturation is equal to VCC divided by RC to calculate the saturation value. So this one is to calculate saturation value. This one saturation happen, so we were using this formula. Okay. So the voltage across the CE will seem shorted, so the collector and emitter is 0 volt lah. Okay. So this one is saturation. Exercise. So until here and the exercise, if have time we do together. If don't have time, you go back to lah. Okay. DC load line. So cut off and saturation can be illustrated in this relationship lah. In this collection, this curve is known as collector curve by a load line. This one is a load line. Okay, the ideal cut off, the IC is 0. Ideal case this IC is 0. You see. Okay, VCE is same. So at here, if 0, VCE and VCC is the same. So and saturation when this IC here, when IC equals to IC saturation, maksudnya this one is the cut off. When they increase until maximum saturation, this is saturation happen. Okay. Saturation have happened. This VCE is equal to VCE saturated. Maksudnya dia sampai maksimum. VCE sampai maksimum sudah. Okay. Until maximum. So between this cut off and saturation, we can draw this road line. This one, red color line. This one is cut off. This one is saturation. So kita boleh draw this line. Okay, understand? Okay, so when the cut off is along this root line, we known as active region. So yang between this one lah, active region. Okay Okay, now two end of this root line this root line is the lowest point IC is set. So this one is the IC is 0, so at the lowest point lah. You see this one, if 0, if your current 0, your V also 0, so everything is 0. You draw a straight line. Nampak kan? Okay. So this one is the lowest point lah. So given IC is equal to ICE, VCC equals to VCE. So if the upper point here happen when your VCE is 0, and then your current at the saturation, VCC maximum lah, VCC divided by RC, so you can get this value. And this is how we do calculation. So now we go to calculation. We finish this calculation, we can be going back. Dapat textbook ada jawapan kan? Slide ada jawapan tak? Tak ada? Ada. So you see the answer in the slide? Can ah? No. Yang mana I calculate here? I calculate fast. Okay. We finish this question, we can go back already. So first, assume VCE saturation is 0.2. Determine this resistance in saturation period or not. So this one in saturation or not. So you have to determine 0.2. Adakah dia saturated or not? Okay. First, you have to whether saturated or not. So first you have to calculate your VCC minus with your because like this, you have to find your IC saturated. So if you see your IC saturated is what formula? VCC divided by your RC. Betul kan? IC saturated. Okay. Now they told you VCE is saturated at 0.2. So you have to consider this VCE saturated punya happening. So you take your VCC is 10 volt from here. Your VCE is here. VCE saturated is here. This one. Here is VCE saturated is 0.2. 0.2. Okay. So this one you have to minus off this voltage. You only can get this VCE, right? Betul kan? Betul kan? But to calculate this one, you have to take VCC minus all your VCE. You only can get your current at here. Betul tak? Betul kan? This one minus this one, you only can get this one. So you take your 10 minus of 0.2 volt divided by your RC. 10 kilo. 1 kilo. So you get 9.8 milliampere. Okay. Okay, now you see if your IB is large enough, they will produce your IC saturation. Okay, so now you want to calculate your IB. IB here, this one. So IB take this one minus off. Here, you will get the IB lah. So IB, you know your formula is VBB minus VBE divided by your RB. Okay, VBB is 3 minus off 0.7 volt divided by your RB is 10 kilo ohm. Okay, how much? 0.2 3 milliampere. Betul kan? Dah. Okay. So now you know your IB already. So you have to find your IC. Okay, you have to find your IC equals to beta multiply your IB. Beta is how much? 50. IB is 0.23 milliampere. So you get your answer. How much? 11.5. Okay. So when you get this answer, so okay, is it show saturated? IC is greater than. Tu tengok kan? Sini graph. Kalau nak saturated, mesti ICU bigger than I saturated. Baru saturated. IC must be bigger than your IC saturated. Only is saturation. So this one, is it bigger than this one? 11.5 bigger than 9.8, right? Yes or no? Yes means saturated. Now this is how we determine. Okay? Okay, now you go back, you determine. Now you change. You change this question. Okay, you change here to 100. BBB you change to 1.5. You change all, you calculate. Okay, and also RB you change, RC you change, BCC you change, and then you determine whether it's saturated or not. Same method. You change the value and calculate. Boleh? So next one is homework. We discuss next class. So now we come to the end of the class. So this is the summary. So from this chapter you learn about transistor. So what is this? Yes, good. Then if you see this one, the arrow going down is what? Going up? So the last one is transistor. Good. Okay, next one. Okay, so if you see this transistor, so what is your formula for current emitter? Okay, good. So this, if your VPE, you will get 0.7. For this one, NPN. So if PNP, you will get minus. Okay. So next one. So when you see this circle is your amplification circuit for the transistor. So to calculate IC gain, what's the formula? Okay, good. So next one, the IC voltage again equals to VC divided by VB, RC divided by R prime C, R prime E. Okay, Okay, next one. Okay, go to switching. So if you see this one is cut off, right? Yeah. So when cut off circuit, your EC junction is DC reverse bias. Okay, so for saturation, forward bias. Okay, very good. The next one, last one. So summary. So this circuit is what circuit? What type of bias? Voltage divider bias. And the next one? Yeah, collector, feedback, bias. So the next one? Emitter, bias, base bias. So at the end of this, you might be able to do all these calculations. Okay, so thank you, class. And then, this one is your resistor lah. Come here, you don't go at the back and then you cannot see. Come, if you want to do recording, come in front. Come nearer. Ask the one do recording. And then, here got chair, you can sit down. You can sit down, come. The back one will come nearer. You can sit here or whatever. So this connection, at first you have to connect this one power supply, 24 volt. If you see this diagram, right, 24 volt. This diagram, 24 volt. You have to connect to the transformer. So this one is a transformer. And then you have to connect, this one is positive, this one negative. So these two wire you have to tap at the back lah. Okay, after that you connect already. So first, red wire, you have to connect, this one is transformer lah. So red wire you have to connect to your, what is this? Diode. Okay, connect to your diode. Okay, after you connect to your diode, this one lah, black color. Then to silver side lah of the cathode. Silver is the cathode. And then connect to this resistor, 1 kilo ohm. Check your resistor whether it's 1 kilo ohm or not. If not, you take the wrong one. Check with the multimeter. Okay, and then go to the ground. So you connect to the black color ground. So this one you come from here ground. So you take the red to red, and then this ground you to red. Okay, this one is this one lah. Okay, after done already, here you have two prod 1, prod 2. So you can connect lah. So you take your prod 1, yellow color, you can connect. It's okay lah. No mind lah. I reverse it lah. Okay. So green color I put as input lah, prod 2. Yellow color I put as prod 1. Okay. So you connect it. Your probe already. This one, remember your probe have to calibrate lah. Everything calibrate first. Okay. Then you connect like this only. You on. Okay, this one we use with big power 24 watt boleh mati punya. 24 watt can die. So you have to be careful. That's why I say safety very important. So when you on, okay, you will get this graph. So if you cannot get, you just click auto scale. Okay, it will come up. So you can adjust you can adjust up down. This the yellow one is your this one your output lah. So you see you will get the green one is a sinusoidal.
Half wave rectifier.
Okay. You can adjust up down lah. You can see I adjust up. Okay, you can see this one. So this one is your full wave sinusoidal graph. Is an input. So you will get the half wave.
Then after that you need to get this figure.
Error. How can I find error?
This only have the
Formula. Okay.
expectation
Was I get it right?
divide by this one.
Actual. What's actual?
Actual is the one you got.
No, the BDC.
Yes. Then you divide by this and multiply by 100%. Then you get.
First, you have to check the condition of the diode. So follow this one. So this is multimeter. Multimeter, this one is a diode. So first you have to turn this one to the diode. Okay, and then you have to put your leg as anode and cathode. Okay, you put inside. So you read the reading.
Okay.
Okay, 0.8. So you have to record here. Anode to cathode, 0.8. Okay, and then cathode to anode. Okay.
Opposite.
Opposite. Turn it. Switch on, you turn it, so how much? So you measure. It's supposing it's no value, it's zero. No, you have to put to here.
Oh, okay.
It's zero.
It's
Because,
zero.
yeah, zero? Zero,
Zero,
L.
zero, zero.
Yeah, because this one, we are measure the diode.
Okay.
Boleh nak pukul saya? Okay, like this. Okay, after you measure finish already,
Yeah.
then you start the second step. Construct the network of this figure. So you connect lah battery to diode and then to your resistor. Okay, okay, okay. You connect. Connect. Yeah.
Yang ini musuh buat main. Calculate yang ini.
Kat mana? Yang ni, kita calculate yang ni. So kalau you ukur, dapat 1K. Okay, nak kena apa?
Yang ini macam buat.
Okay, dia dah sub connection kan? Okay, dah sub connection. Pertama you kena ukur V1. Okay, awan-awan dulu. So awan punya ohm berapa? 1 kilo.
Satu.
1 ke 100? Ni 100.
Oh ya.
Kena pilih yang 100 punya untuk guna. Jangan pilih salah. Dan ini banyak. And yang resistor ni kan banyak. So first ambil resistor ni ukur dengan multimeter. Okay, pilih mana satu yang betul. Kan dekat modul kena guna 100 kilo. Ukur lah mana satu yang 100 kilo ni ya. Dekat multimeter. Ini berapa? 6 apa? 66 okey tak nak. Okey ni pula. Mana yang 1 kilo punya? 1 kilo 100 kilo ohm. So pakai yang ni. Yang lain tu simpan. Buat yang tu. Okey lepas okey buat pasal ni. Pasang, okey. Okey, siap pasang. Lepas tu, okey. You kena check you punya ni betul tak? So, kaki tengah B. So, ini kolektor betul tak? Dah check ke belum dengan kaki? Okey, komponen gambar ni lah. So, gambar ni macam ni. So, kaki atas tu kolektor lah. B, bawah tu emitter. Betul lah tu. Okey, lepas tu. Okey, so yang B ni sama bagi resistor, C ni sama bagi VCC, so yang ni bagi VCC lah. Yang ni bagi VCC, bagi VCC sini. Seperti yang roll ni, roll ni. Okey, dalam video tu kita nak sama siap-siap.
Oh ya.
Video tu kita dekat belakang. Okey, so yang ni pergi dekat ground kan? Okey, ni betul dah. So yang 15 sini. Okey, tengok kat sini. So kalau boleh kita guna channel 2 dengan 3. Sebab channel 1 dia maksimum sampai 5 watt je. So yang ni dia boleh sampai 30. So kalau boleh tukarlah.
Tukar satu, tukar dua.
Tukar yang ni apa? Yang ni VCC kan? Dalam video
Ya,
kan
VCC.
ni VCC ni BBB kan?
Ya.
So yang ni BBB. So dalam video saya kata yang ni siapa dia yang ni? Okey, yang ini pula suka yang ni. Okey, dah tukar. Okey, dah confirm pasangan betul kan? Pasang boleh lah. Okay. Macam ni dah betul. Okay, lepas tu first step you tengok sini. First you kena calculate kan. Calculate V1 required to generate 5 volt daripada table ni. So you check table ni. Okay, yang ni 100 kan. So 100 darab dengan 5 V equals to IR kan. 100 kilo darab dengan 5 mu ampere you dapat 500. Mu ni mu. Mu tu negatif.
Negatif 6.
Ya, negatif 6 ni kuas ni 100. 100 kan ni 100K. So 100K mas darab dengan kuasa 6, kuasa negatif 6 dapat berapa? 0.5. Ni 1, 2, 3, 4, 5. So isilah. Pen mana pen? Isi. Isi dengan pensel dulu pun tak apa. Nanti balik isi dengan pen lagi. Okey.
Very good.
10 darab dengan 100 so 1 lah. Ni 2, 3, 4, 5. Saya kira dah kan? Okey, saya kira lepas tu saya dalam video saya pilih yang nombor 2 sebab kan tadi Dr. Nazak dia bagi tahu nilai yang atas tu pun kecil. So kita start dengan nilai yang besar dulu supaya boleh dapat nilai. Okey, so dah siap ni kita set nilai 4 dulu. Kita set nilai 2 ataupun set nilai 4. So letaklah punya first you kena ukur you punya V1. Ambil resistor ni, letak dekat V1 you. Resistor 1. Kecil resistor ni. Letak macam ni. Okey. Ni letak kaki dia kat sini, satu kat sini, satu kat sini. You letak kaki voltage. Okey, you ukur voltage sekarang berapa? Kosong-kosong tak ada current. So kalau ada you on lah. Okey. On dulu. Tak ada. You ukur. Ukur kat sini. So sekarang kita tadi kan yang tu VBB kan? VBB kan? So you kena adjust yang nombor 2 VBB kan? Nombor 2 you kena tekan 2. Okay, so yang ni you adjust lah. So yang bawah ni you select 0.5 first. Okay, enter. Okay, lepas tu ni atas ni you set kepada 2. Enter. Nah, you check sekarang berapa watt. You kena on dulu. On ni kasi on. Okay, dah terbalik dah.
Balik
Sebab kalau negatif. Letak betul tak? Okey. Letak dekat cucuk atas atau betul. Okey, ni kan 1.3 kan. So you kasihlah adjust sampai dapat 2. So mungkin I letak 2.4 kot. Okay, enter. Lagi sikit.
Lagi sikit.
Lagi sikit. So kita adjust. Okay, naik lah. So boleh nampak dalam video kan. Okay, adjust. Sampai dah dapat
2.
2. Dah lebih dah.
Kurang sikit.
Okey, agak-agak boleh lah kan. Okey. So dah dapat 2, lepas tangan tu. Okey, so sekarang kita nak nilai VCE kan. Okay, VCE kat mana? VCE kat mana? C lah ni dengan E kan. So you punya multimeter letak C dengan E. Letak. Letak kaki C yang ni. Kaki C yang ni. Dan kaki E yang ni. Nampak? Okay, letak. Ukur. Letak sana. Okay, dah letak kan? Okay, sekarang kan nilai dia tak banyak kan? So kita semua nak 4 word kan? Okay, 4 word you pergi kat channel nombor 3. Okay, sekarang kita pergi channel nombor 3. Ini dah buka. Okay, sekarang kita pergi channel 3. Okay, sekarang main channel 3. So sekarang kita adjust yang bawah ni pergi 0.5 dulu. Enter. Sebab ampere. Ampere. Okay, atas ni kita nak 4 kan? Tak 4. Enter. Okay, check. Sini dapat 4 tak? Oh, sikit lagi nampak. 3.97. So kita adjust sikit lagi. Dapat 4. Sorry. Adjust tempat salah pula.
Betul. Select dulu.
Select dulu, baru adjust. Tak boleh juga.
Ya. Yang belah sana ada tu.
Oh, ni current. Sorry. Okey. You nak 4. Dah 4 dah. Sikit je. Okey, dah 4 dah. Okey. So sekarang 4 dah kan ni. Ni dua-dua dah cantik dah. Okey, baru sekarang you nak ukur IC. Okey, IC petak ni kena isi lah. IC kena break kaki C.
Itu ukur kan?
Break kaki C ni. So you break kaki C. Kaki C ni kan? Hang cucuk salah ni. Ini dah break dah kaki C. Nanti kena cucuk balik dekat ni. Okey. So sekarang ukur kaki C. Ukur. Ni tukar pergi current dulu. Okey, baru ukur. Dah jalan kan? Sekejap. Okey. Break kaki C. Ukur balik. Puluh 31. You berhenti salah bagi dia nak. Tak. Bukan you berhenti. Bagi dia tunggu naik. Tunggu sat. Bagi dia naik. Sampai dia punya nilai tetap sikit baru you catat. Yang gerak tangan you. Dia gerak, dia ikut gerak. Dah turun balik dah kan. So 31.5 macam tu lah. So you isi kat sini 31.5. Isi kat sini. Isi lah 31.5 miliampere. Kan kat sini. You isi lah sini 31.5 miliampere. So lepas tu you ukur pula nilai yang lain-lain. Sekarang you dah fix yang ni kan tadi ke
4 lah.
sorry. Ya 4 kan. Kan nilai ni dah fix. So you boleh buat satu row pergi ataupun you boleh buat satu row turun. So satu nilai you dah fix. Kita dah ada ubah dah. So you buatlah atas, you ajak atas dengan bawah. Lepas tu yang lain-lain kasih adjust juga.
Okey.
Dia sama lagi.
Okey.
Yang ni US satu sama dia okey dah letak resistor satu. Sini. Okey, dah letak. Lepas tu adjust yang ni sampai dapat nilai ni 3. Sama nilai ni 3. Okey, so kita adjust. So sekarang adjust lah. Tak. Jangan gerak. Terbalik dah ni kaki ni ha. Merah dengan kaki hitam. Okey, ni sekarang 2 kita adjust ni sampai dapat 3. Nak ada banyak ni. Belum lagi. Tunggu sat. Naik lagi. Sampai okey, dah lebih dah. Kurangkan sikit. Boleh dah dekat-dekat 3. Jangan you kan, jangan gerak-gerak. Dah 3 dah kan. Okey, so lepas tangan. So sekarang kita break kaki ni. Okey, ukur. Cepat ukur tukar current. Multimeter current. Okey, ukur current. Okey, berapa dapat? 1, 5, 5.4 contohlah. Ya, macam tu. Okey, sambung lagi next. Sampai pasang balik. Lepas tu okey, lepas tu adjust yang mana? Adjust mana?
Yang hijau.
Hijau. Okey. Okey, tak apa, you tolong. Tolong you adjust. You tolong tengokkan. Ni tak tukar lagi. So, adjust kat sini kan? Betul kan? Okey. Adjust sekarang nak berapa nak? 4. 4. Dah nampak ke belum?
Belum.
Hang ni tak tengok. Dah. Okey. Jangan je gegar. Besar sangat nilai tu.
Okay, so first we calculate our V1, which is 5.0. We are measuring using our multimeter. We have adjust the reading here.
Now your VBB is value how much?
Supposed to be 5.0.
Okay, 5.0. Okay. Okay.
So now it's 5.0.
Okay.
So now we can calculate our VCE. So VCE, if you are calculating 1.0,
We need to adjust our VCC lah.
we need to adjust, and we need to let the multimeter to be 1.0.
Okay. So your multimeter value is VCE, right?
Yeah.
Yes.
Okay.
Now,
轉出位。
Okay.
okay, so we get
1.
1 volt.
Okay.
So now we will calculate our.
You want to
IC.
measure your IC.
So we break the circuit.
You break the circuit.
Yeah. 14.28.
Okay. So how many value you measure already?
We measured for one row.
Okay. So later on, if you measure for second row, what your expected result will get?
Before 0.5, you have a large increase.
Mhm.
After 0.5, you will exceed the saturation region, and then the increase of IC will be very little or very little. So the graph
Gradually
will be,
increase.
constant.
will be something
Remain-
like this, since it does
okay.
not exceed the
this
breakdown
index.
voltage.
Okay, good. So what is the function of BJT?
BJT,
Yeah lah, now you're doing BJT, right?
yeah,
So what is their function?
to produce.
They can act as a switch and also as an amplifier. So if we do our IB for 40 microampere, so we compare between the value of 40 and 50. So it acts as an amplifier lah. So when IB is larger, our IC will be larger.
Okay, good. Okay, good. Thank you. Okay, after your circuit is correct, so first thing you have to set this value to 4. So 4 you have to measure at V1 is 4. So you put this one, you adjust to here, voltage, and then you put. Now you have to get this V1 to become 4. Okay? Okay. Okay. Okay, now you, because this one already the leg, okay, so now it's 3.2. Okay, so this one 3.8, so we adjust. Wait. So this one you put 0.5 first. 0.5 for the current. For the current, okay, 0.5 ampere, and then now this one you have to set to 4. 4 Okay, enter. So, but you see the value didn't get 4, so you adjust until you get 4, so maybe 4.5 lah. Enter. Increase a bit, right? Adjust a bit. Adjust until get 4. Okay, roughly here for voltage 4 already lah. Okay, now you take out. Now you want to find here this one for your V1. So your VCE, okay, you put 6 lah. You want to measure this value, right? Okay, 6. So you have to put this one to your VCE. C is above here. E is below. Okay, now this circle you have to put this current to this leg. To this leg. Okay. This one you have to put correctly because this one you didn't put correctly. So after that, you measure VCE. Okay, now you see the value is 4. Here 4.9, right? So now you want 6. If you want to do 4 also can lah, 4 and 4 lah. So here you adjust lah. So check channel 3. You adjust this one. This one 0.5. Okay, so channel 3 you adjust the voltage to get 4. So now voltage is 4. Okay, 4 already, right? So then you only break the IC. You want to measure IC, right? So you break this one. So you adjust this one to current. You put in, you measure. So now is how much? Okay, 14.6 I7. Okay, 14.8 lah, you say. So you can write your answer here. 4 and 4, 14.8. Okay, now you increase to 6. Okay, now you put your VCE. You put your kaki VCE. You put this one to back. back here. Connect back the leg. And then you measure like this. Then you adjust to V6. Adjust. You can click 6. Click 6. Enter. Okay. So see here. Okay. So it is 6 here. Okay, see? 5.9. Okay, adjust a bit. Just increase. Okay, lagi. Okay, good. So now 6. So you break the leg. And then you measure current. Yes, good. Okay, now 155.
15.4.
Right now 15.4. 15.5. Okay, now 15.5. Okay, so you will follow up later on. This one keep increasing, but slightly increase. So you next now you do. Okay, now you connect back this leg. Okay, so you measure VCE. VCE measure.
Here?
Here. No, this one is B, kaki C. Here, this one. Okay. So you see now it's 6, right? So you want 8, right? So now you adjust to 8. Okay, no, I cannot adjust. That's why I say need 2%. So 7.9. So you adjust it lah, kasi 9. See below. Okay, good. It already. Okay, so break the leg. Okay, and put to current this one. Okay, you measure. That's why I said need to Google. You wrongly measure this one and this one, the leg that you break. Okay, so now 15.
Measure for IC for VCE 2.0. First of all, measure the VCE. Okay, so the multimeter one can just become 2.00. Okay, break the circuit. Okay, now break the circuit to find the IC. So tak ni tadi 10 ni.
Okay.
Tu kau jadi jari.
Slow tak apa. Slow. Dia nampak saya dia takut.
Tu 10.
Okay, 10. Okay. 10.8. Okay, 10.8. Okay, continue. Next reading.
Reading 4. VCE 4.0.
Okay, you adjust VCE.
Yes.
Okay. Sini 4 ah? Okay, 3.995. Okay.
Adjust more to
Okay.
4.
Okay, good.
Okay, so IC break the circuit.
Break the circuit.
10.56.
Okay. So you get 10.56.
56. So it's still increasing. 10.58. Maybe something wrong here.
Okay.
Okay, recheck.
Okay, boleh.
Recheck.
This one.
Okay, dah recheck balik tadi. So maybe tadi kan dia stick sikit.
Okay,
10.21.
10.21.
Yes.
10.21.
Okay.
Okay, this one 10.5. Good, good. So later on you measure this value well?
Maybe increase it but adjust a little. Because
Yes.
the graph will be like
So
because the-
okay. Because what?
because the VCE the limits. I see the limit maybe 40 volts.
So they won't exit to be saturated.
Yes.
Yes. So this one is a characteristic of BJT. Good. Okay, then you answer me. So what is the function of BJT?
Macam BJT ni untuk kita nak control
Nak control apa? Dia boleh function macam?
function untuk kita apa tu? Nak current ni untuk kita macam mana nak abang?
Nak cakap
Macam mana nak abang betul?
Bila current IB increase,
Ya.
so IC dia akan increase. When dia increase sampai certain value dia akan apa?
Dia akan
Saturated.
saturated, so dia tak ni dah. Apa dia naik
Betul. So dia akan boleh as function dia sebagai macam switch lagi. Jadi amplifier, control the current. Okay, bagus.
Kita nak tunjuk level.
Tak payah.
You have to change here.
Okay, change.
2 points. No, you just randomly click and change. Then enter. So you read 2.0. So now you have to see here. Put your multimeter. Put here. The first leg and the third leg. Reverse terbalik.
Not yet,
Come.
not yet.
Your current is out. You have to pasang inside. Now measure. The third and first. Okay. Now you get 2. No, you have to focus here. Someone will help you. So you get 2 ready.
Okay, 2. Okay.
And then you already get 2. Now you have to calculate the current.
You have to cabut
Then you have to change here also multimeter to ampere. From the last leg to the current outside. No. Okay.
middle one.
The last one. 8.41.
Okay, right.
It will decrease.
Okay.
We put the current one. So here we get 5 volts from V1. So dia dapat V1 5 volts. So kita nak cari IC. So untuk IC daripada VCE ni kita pakai multimeter. Contoh kita ambil dari 8 volt. 8 volt masuk. So measure VCE dulu. VCE sini dan sini. So kita dapat 8 volt. So dah dapat 8 volt sini baru kita cari IC. IC dia cabut sini. Lepas tu connectkan multimeter dengan collector. So we got 0.4.
Okay.
So kalau dekat sini kami dapat tadi 0.3.
Okay, bagus. Okay, continue.
So we try 6 volt pula. 6 volt. 6. So kita kira VCE dulu. VCE. So we get 6.02. So we try cari IC. Tengok dia. Cari IC dia. So dapat 0.24.
Okay.
Kalau kat sini dapat 0.23 minit.
Okay, bagus. Boleh? Bagus lah.
Void. Dapat 4 void.
Okay, bagus.